If you fell into a black hole, you wouldn't hit the singularity first. You wouldn't see a glowing tunnel. You wouldn't instantly be crushed into nothing. And for a while, you might not even realize anything is wrong. A black hole doesn't look like a hole. From a distance, it's just a region of space where gravity has become so extreme that nothing, not even light, can escape. At the center of most galaxies, including our own Milky Way, there's one. Ours is called Sagittarius A star. It has the mass of 4 million suns compressed into something smaller than our solar system. But what actually happens if you fall in? First, you'd approach the event horizon. This is the boundary, the point of no return. Once you cross it, escape becomes physically impossible. Not because something blocks you, but because all possible paths through space now lead inward. Here's the strange part. If the black hole is large enough, like the supermassive ones at galactic centers, you wouldn't feel anything dramatic as you cross the event horizon. No wall, no flash, no sudden impact. From your perspective, you just drift past an invisible line. But from the outside, everything changes. To a distant observer, you would appear to slow down. As you get closer to the event horizon, time for you stretches. Your light becomes redder and dimmer. You seem to freeze at the edge, fading away. They would never actually see you cross it. You would just disappear. That's time dilation. Gravity doesn't just bend space, it bends time. Now inside, gravity starts to reveal its true violence. The closer you move toward the center, the stronger the difference in gravitational pull between your head and your feet. This is called tidal force. If you're falling feet first, your feet feel a much stronger pull than your head. The difference stretches you. Physicists call this spaghettification. You would be stretched thinner and thinner, pulled into a long, glowing strand of matter. At the same time, you're being compressed sideways, pulled apart and squeezed together. Every atom in your body being forced into alignment along one direction. In smaller black holes, this stretching would begin before you even cross the event horizon. You'd be torn apart before you ever enter. But in supermassive black holes, the event horizon is so large that the tidal forces at the boundary are weaker. You could cross it intact, but not for long. Eventually, the stretching becomes unstoppable, and then comes the singularity. According to Einstein's general relativity, all the mass of the black hole collapses into a single point of infinite density, a place where space-time curvature becomes infinite, where our equations break down. But infinite is usually a sign that we're missing something, because general relativity explains gravity beautifully, but it doesn't include quantum mechanics. And at the singularity, gravity becomes so extreme that quantum effects can't be ignored. This is where physics fractures. Some theories suggest the singularity isn't a point at all. Instead, it might be a tiny but finite region where quantum gravity takes over. In loop quantum gravity models, space-time itself has a smallest possible unit, meaning true infinities may not exist. Other ideas are even stranger. There's the concept of a firewall, a hypothetical wall of high-energy particles at the event horizon that would instantly incinerate anything falling in. This idea came from attempts to solve the black hole information paradox. If information can't be destroyed in the universe, what happens to the information about everything that falls into a black hole? Does it get trapped forever? Does it get encoded on the surface? Does it leak back out through Hawking radiation over trillions of years? Hawking radiation is another twist. Black holes aren't completely black. Because of quantum effects near the event horizon, they slowly emit radiation and lose mass. Over unimaginable timescales, even supermassive black holes evaporate, which raises a disturbing possibility. If black holes eventually evaporate, and if information must be preserved, then somehow everything that fell in is still encoded in the universe, scrambled, diluted, but not erased. Some speculative models go further. They suggest that the inside of a black hole could connect to another region of space-time, a white hole, or even a new, expanding universe. In this view, black holes might be cosmic seeds. Every time one forms, it gives birth to another universe on the inside. If that's true, our entire universe could exist inside a black hole formed in another cosmos, and we would never know. Because once you cross the event horizon, every possible future leads inward. The singularity isn't just ahead of you in space, it's ahead of you in time. It becomes your future, as inevitable as tomorrow. There is no turning around, no steering away. Inside a black hole, the roles of space and time effectively switch. Moving toward the center becomes as unavoidable as moving forward in time. You can't choose not to fall toward the singularity any more than you can choose not to move into the next second. Eventually, whatever lies at the core, singularity, quantum core, or something we haven't imagined yet, ends your journey. And that's the unsettling truth. Black holes are not just objects in space. They are places where our understanding of reality stops working, where time stretches to infinity from the outside, where space collapses into inevitability on the inside, where the laws of physics, as we know them, reach their limit. And somewhere in the center of nearly every galaxy, one waits.